This video module will introduce the flight control surfaces and associated components on the wing of the Boeing 767. It will describe the function and operation of the control surfaces, as well as show access and location of the major components. The flight control surfaces include the ailerons, spoilers, flaps, and slats. The flight controls are powered by pressure from the hydraulic systems. In the event of a dual engine failure, the ram air turbine, or RAT, is deployed. This provides the necessary power to the primary flight controls to maintain control of the airplane. New lightweight materials are used extensively in the manufacture of the 767 flight control surfaces and associated hardware. Graphite epoxy materials have been incorporated into the flight control surfaces. Titanium, fiberglass, and advanced aluminum alloys are used in the supporting structures. We will take a look at each of the control surfaces, beginning with the ailerons. Since the right and left wing components are similar, we will be primarily concerned with the left wing and only refer to the right wing when circumstances warrant. The ailerons are located on the inboard and outboard trailing edge of each wing. They provide lateral or roll control of the airplane along the longitudinal axis. Each aileron is powered by two power control actuators. These are powered by independent hydraulic sources. During takeoff and landing, the inboard ailerons are in a drooped position. While in this position, the ailerons assist the trailing edge flaps in creating increased lift for takeoff and better drag characteristics during landing. The ailerons are controlled by pilot input commands on the control wheels or by the autopilot control system. Atop each control wheel is the aileron trim indicator. Also located on the flight deck are the warning lights for aileron lockout on the overhead panel, two ICAST display screens on the pilot's main panel, a status button below the screens, and aileron trim switches on the aft end of the control stand. The flight control shutoff switches and flight control off lights are located on the right side panel. Located in the forward equipment center, which is accessed through the electrical electronics bay access door, are the forward quadrants. Each quadrant consists of an input drum and drive drum. The captain's quadrant has a field force transducer, while the first officer's quadrant has a load limiter assembly. The primary cable, which is connected to the drive drum, continues from the left forward quadrant to the left wheel well quadrant located in the left wheel well. The trim motor is attached to the quadrant, as is the fuel center and trim assembly. Lateral trim switches on the control stand regulate the trim motor. Also located in the left wheel well are the upper and lower lateral central control actuators, or LCCAs, and left LCCA output quadrant, from which the cables extend to the left wing. Attached to the aft bulkhead of the left wheel well is the center system hydraulic shutoff valve for the ailerons and spoilers. Similar valves for the left and right systems are found between the inboard aileron and inboard flap on each wing. Outboard of the shutoff valve are the inboard droop quadrant, trailing edge drive angle gearbox, outboard droop quadrant, inboard power control actuators and reaction link, and inboard position transmitter. Cables from the droop quadrant attach to the outboard aileron lockout mechanism. This mechanism permits full aileron travel at low air speeds while preventing outboard aileron control at high air speeds. A linkage then attaches to the outboard power control actuators, reaction links, and finally to the outboard aileron. Near the outboard end of the aileron is the outboard position transmitter. The components in the right wheel well for the right wing differ slightly from those of the left wing. Outboard of the right wheel well quadrant is the right torque tube with a lost motion mechanism. Beyond the torque tube are the right LCCA, right LCCA output quadrant, and the right aileron control output quadrant. From here the cables go to the right wing. Each outboard aileron lockout mechanism is operated by an electric actuator. This actuator receives control signals from its respective stabilizer and aileron lockout module, commonly referred to as SAM, located in the main equipment center. The SAM receives electrical signals from one of two digital air data computers, also located in the main equipment center. During cruise, the electric actuator receives control signals to reconfigure the output linkage to the outboard aileron actuators. Adjusting the linkage prevents control inputs from reaching the outboard aileron actuators. In addition to the ailerons, the spoilers also assist in providing lateral control of the airplane, as well as braking capability in flight and ground speed braking after landing. There are two inboard spoiler panels and 4 outboard spoiler panels on each wing. The 767 is the first commercial airplane to use an all-electric spoiler control system. This is commonly referred to as a fly-by-wire system. The fly-by-wire system eliminates the long cable runs from the flight deck to the spoilers. The advantages are a reduction in response time from the input command to control surface deflection and the elimination of time-consuming cable rigging. The spoilers are controlled by manual input commands on the control wheels or the speed brake lever. Input commands may also be generated by the autopilot system. Command signals are sent to 6 spoiler control modules located in the main equipment center. These modules interpret both the input signals and position feedback signals. Located on the P5 overhead panel are the amber indicator lights for the spoilers and auto speed brakes. Inside the control stand, beneath the speed brake lever, are the no-back clutch, 6 linear variable differential transformers, or LVDTs, for the speed brake lever, a speed brake arming switch, and a speed brake lever position switch. Located directly above the access door to the forward equipment center is the auto throttle quadrant containing the 50% thrust switches. Located aft of the auto throttle quadrant in the forward equipment center are 3 spoiler control RVDTs. These are attached to the upper drum of the captain's and first officer's forward aileron quadrants. Each housing contains 3 transducers. The inboard power control actuators, or PCAs, are trunnion mounted to the spoiler beam. The rod ends are attached to the spoiler panels. There are 4 hinge points attaching each spoiler panel to the wing. The outboard power control actuators are cylinder mounted to the aft wing spar torque tube. Again, the rod ends are connected to each spoiler panel. An electro-hydraulic servo valve mounted on the spoiler actuator receives an input signal which governs the positioning of the spoiler panel. Symmetrical spoiler panels are controlled by the same spoiler control module. The high lift flaps and slats are the final sets of flight control surfaces on the wing. Inboard and outboard flap control surfaces are located along the trailing edge of the wing. There are 6 leading edge slats on each wing. 5 slats are outboard of each engine, and a single slat is inboard of the engine. The flaps and slats increase lift by increasing the wing surface. Increased lift allows the airplane to take off and land at lower airspeeds, as well as improving climb-out performance. The flaps and slats also decrease operating airspeeds, thereby minimizing ground roll. Reduced ground roll results in less wear on tires, wheels, and brakes. The flaps and slats are either mechanically controlled by the flap lever or electrically controlled from the alternate extend panel on the pilot's main instrument panel. The flap lever has 7 detented positions: up, 1, 5, 15, 20, 25, and 30. Positions 1 and 20 have flap gates. Flap and slat system control components are located on the P3-1 panel. These components include amber leading edge device warning light, amber trailing edge flap warning light, flap position indicator with separate needles for left and right wing, alternate flap selector, alternate leading edge switch, alternate trailing edge switch, and ground proximity flap override. The Flap and Slat Electronics Unit, or FSEU, is located in the main equipment center on the E2-4 rack. The trailing edge aft quadrant is located in the forward end of the aft cargo compartment. Situated in the aft end of the right wheel well are the flap load relief actuator, trailing edge gearbox, trailing edge control module, trailing edge bypass valve, and flap power drive unit. The flaps and slats hydraulic shutoff valve is also in the right wheel well, outboard of the power drive unit. The inboard flaps are double slotted. When the airplane is in the cruise or 0 unit position, the aft and main flaps are nested to the wing. During takeoff or the 20 unit position, the aft and main flaps are separated from the wing. When the inboard flaps are fully extended for landing, the 30 unit position, the aft flap, main flap, and wing are separated from each other. The outboard flaps are single slotted. The flaps and wing are nested when retracted and separated or slotted when extended. When airspeed becomes excessive, a load relief system prevents extension of the flaps to the 30 unit position to prevent structural damage from occurring. A drive arm attaches the linkage system to each rotary actuator and flap surface. As the actuator drive arm rotates, the linkage extends or retracts the flaps. The conventional transmissions and jack screws have been eliminated. This feature has created a substantial weight savings and reduced the number of moving parts. We will now look at the major components of the leading edge slats. The slat aft quadrant is mounted on the aft bulkhead of the forward cargo compartment. The torque tubes pass through the bearing supports, also mounted on the aft bulkhead. The inboard leading edge power drive unit is located in the right strakelet. When the panel is removed, the components can be seen. These include the input crank, control unit with dual RVDTs, hydraulic motor, control valve module, bypass valve with manual lever, and electric motor. Each inboard slat has 3 main support tracks, 3 programming tracks, and 2 inboard leading edge rotary actuators. The outboard leading edge power drive unit is located in the left strakelet. Its components are similar to those of the inboard PDU. Components common to the outboard slats include the inboard rotary actuator, bearing support, outboard rotary actuator, and safety strap. Each outboard slat has 2 main support tracks, and 2 programming tracks. This video module has introduced the flight control surfaces and associated components on the wing of the Boeing 767. It has described their function and operation, as well as shown access to and location of the major components.